Well, hello, everyone. Welcome to the GLOBE program's Great Global Investigation of Climate. My name is Professor Todd Ellis, and I'm an atmospheric scientist at the State University of New York College at Oneonta. I'm also the education and outreach lead for the NASA CloudSat mission, which studies clouds and their roles in influencing Earth's climate. And I'm really happy to be here today on World Water Day to talk with you and learn about all of the ways you have and will continue to explore the question of what is your climate. I'm hopeful that at the end of this brief presentation, you'll participate in our online forums and ask some of the questions that have come up and share some of your stories about some of the ways that you have been studying the climate this past couple of weeks and how you plan on studying it moving forward. In this particular part of the study, the part that we're just now sort of getting through, we have focused primarily on temperature and precipitation. And if you saw my earlier video presentation, you will understand that that wasn't by accident. Temperature and precipitation are the primary atmospheric measurements we monitor to determine climate, in part because they are measurements that scientists have taken for hundreds of years. And since the late 1800s, scientists realized that it's important that these measurements should be taken the same way every time, using similar instruments at every station. By doing so, we have consistent data that can be compared around the world. And I find it interesting that one of our participating schools here in the United States, in the state of New Jersey, is studying how the temperature varies due to different kinds of land cover. You know, how does the temperature differ in grass versus a place where it's paved and vice versa? Imagine what would happen to your data record if one day somebody tore up all the grass around your temperature station and put down concrete. My guess is that your thermometer readings would all be warmer every day forward. That's the kind of thing that we have to account for as scientists when we're studying the climate. And it's something you can study too. So that's why it continues to be really important that from this day forward you continue to observe temperature and precipitation, following the protocols exactly, and in doing it as often as you're able. That way, when you've got many years of data, you too can characterize the climate of your own site. You see, you always have to remember that climate can't be defined by any one measurement. It has to be found using the long-term averages of atmospheric conditions. In order to know the climate at your site, a scientist who studies the climate would want at least 30 years of data to understand what normal is where you live. And then they could use those data to try to answer questions like, what is your average temperature? Does it precipitate often? And if so, how much? These and other questions related to the long-term averages of temperature and precipitation continue to be of great interest to scientists today. Not only that, there are many other scientists other than atmospheric scientists who are interested in the effects of climate, especially on their effect on vegetation and animals, noting that climate can have a really large effect on what can and cannot grow in certain parts of the world, as well as controlling when vegetation appears. For example, we have a school in Croatia who's studying something known as Phenology. These are protocols that are part of the GLOBE program. And Phenology is a study of how climate affects the seasonal cycles of plants and animals. By monitoring plants, you can learn something about your climate and even notice if your climate is changing, if you notice that the flowers come up at a different time each year. This idea of studying the climate in ways beyond just temperature and precipitation actually led to the development of our next activity. You see, in the early 1900s, Vladimir Köppen developed a classification system for climate types using annual and seasonal patterns of temperature and precipitation, as well as vegetation types. In 1954, Rudolf Geiger updated Köppen's system and made it available as a world map. Today, this system, known as the Köppen-Geiger Climate Classification System, is used widely and identifies 31 different kinds of climate regions. There are 5 major types of these climate classifications. Equatorial, which is usually given the letter A, arid, which are given the letter B, warm temperate, which is C, snow, which is D, and polar, which is E. Each type can then be further classified by precipitation and specific temperature conditions. This gives us those 31 different classifications. And the classification that goes with your location depends on things such as how far away from the equator you are, how far away from a large body of water you might be, as well as how high in altitude your station is located. A climate classification can provide great understanding into how temperature and precipitation are both important to climate and important to identifying the kinds of plants and animals that live where you do. The thing is, for any one given school, it can be really hard to come up with that classification without 30 years of data. So to help you with this activity, we've prepared a data set of 30-year temperature and precipitation data from cities around the world. These cities represent each of our globe regions, but more importantly, represent the majority of the climate classifications. Using these data should assist with your identifying your climate classification. And for more instructions, please refer to the user guides that are located on the GGIC web pages. Once you've completed that climate classification activity, we encourage you to post your findings or any questions you have to the Our Climate Classification discussion forum located on the Our Climate GGIC page. But in addition to that, we've prepared some other things that can go with this activity and maybe can help you further refine your climate and compare it to the climate of other schools. If you use the Google plugin, you'll find you can turn on a layer that says Show Great Global Investigation of Climate Participating Schools. This is a KML file. It should give you an image that looks much like the one you see on your screen now. You can then turn on the layer that gives you the Köppen-Geiger classification. That file will give you an image that looks like this and shows you many of the different places where you'll find different climates. You'll notice that in this image there is a classification using those codes, and some of your other information will help you decipher what those mean. Furthermore, if there's a site location indicated in a place, say, that you want to learn a little bit more about, you can click on one of those schools and look at their long-term climate records. So you can get an image like this one, which comes from Cameroon. Using tools like this, you can examine many different climates of our participating schools. They could have the same climate classification as your school, or they could be very different. And once you find a school that you're interested in, navigate to the Our Climate Classification discussion forum and start asking each other questions. Go post to that school's forum topic and ask them about things like what makes their climate unique, what helps determine why they're given that classification, what sorts of things have they noticed in their data. And most excitingly, I think, is the opportunity to collaborate with a school in a different climate zone and really compare how your weather and climate are different. You may find that your weather on a day-to-day basis is very different from what they observe, even if you're in the same climate classification. Plus, if you use these tools, you can go back and look at your own data, the data that you've been collecting for the last few weeks, and decide if they're typical for what's normal for your climate classification. You may find, like I've found where I live, that we've had a much more snowier winter than we usually have in this part of the country. That's abnormal for my climate, but made for a lot of interesting shoveling of snow. If you've never seen snow, trust me, it's not fun to shovel. But now, I want to conclude by thanking you for participating up until this point in the study and remind you that you're not done. We encourage everybody to continue to observe temperature and precipitation and start to build your own climate record. Think about the kinds of investigations that are available to you now that you know something about your climate and the climates of schools around the world. Really go out and try to ask questions of the other groups and participate in the forums. And I think you'll find that finding really interesting questions to answer about your climate aren't too far away. At this point, I would invite you, if you have any questions that you'd like to ask, please go to the Investigating Weather and Climate Discussion Forum. This is located on the Town Hall page of the Great Global Investigation of Climate. And talk with me there. Ask me your questions and tell me a little bit about what you've been doing and what you plan to do. And remember to keep taking those observations. The only way that your school can develop your own climate record is if you have observations over a very long time. So keep that record going. And someday you may be able to look back and say that you participated in creating a climate record for your school. Thanks very much for listening. Good luck in the future, and happy World Water Day, everyone. Take care.